Hello, welcome to the club. You've just seen our premises where SAMYN and PARTNERS team is working about rehabilitation, recycling. This is one of the first things. We restored a ruin in 1993, which was a farm built in 1830 to put our studio, and we're still there nearly 30 years afterwards, enjoying. Nothing has changed. And I've reused every possible brick of the ruin, every bit of stone. Nothing has left the ruin to rebuild the story. By the way, a very funny thing is I was looking at nice slates for the roof to finish the patio, and they are coming from India. This is maybe the only not positive thing about CO2 print, but you have the most beautiful roof slates. So we're busy with a subject which I think is, nothing new. Since antiquity, in scarce economy, or even in less scarce economy, nobody wants to spoil money. And just to start with the argument, everybody is now obsessed by energy savings in running buildings, but very few people really cares about embodied energy. And the reason for that, it is quite difficult to calculate. You can of course get labs results of how many joules or kilowatt hour have been produced, getting out of a steel mill to produce 1 kilogram of steel, but that doesn't give you the amount of joule or kilowatt spent to get that steel welded and put in place, painted and whatsoever. And so we've worked a lot with my engineers here on the subject, and we arrived at a very simple conclusion. After all, the international monetary unit is not the dollar, the yen, the yuan, the euro, or whatever. It is the kilowatt hour or the joule. Because after all, what we do buy is energy. What we do move with energy. I'll give you another example. People speak about mechanical ventilation of building. When people tend to forget that you don't need to have a fan to do that, because when you move a door, you're spending mechanical energy. And that's how we ventilate building, with human power. And this one is free of charge because you get in the building, you still have to open the door. And mind you, we're using that to ventilate the toilets of the future faculty of Applied Science, Brussels University. So ancients were much more subtle in using engineering the right way. And I think that we have spent since World War II a huge amount of time in trying to get a better comfort, to use technology just to satisfy our wishes, instead of using science and technology for health, for happiness, for the happiness of others, for the nature, enjoying everything. So I think and this COVID story, I think is a magnificent opportunity to just rethink how we should behave. Just to remember you, just think about a toilet bowl. Well, and I know in India still, and in many parts of the country, not everyone is enjoying a toilet bowl. And after all, maybe it is, okay, it's better to have one, so don't get into that touchy issue, but the story happened after the dreadful pandemic of cholera in the 19th century. The 19th century has been plagued by cholera from 1820 up to the end of the century. And it is by the big thinking day in Britain that the British Parliament voted in 1850 a law imposing every new housing to have a toilet bowl, a water closet. So you see nothing you understand. So recycling is part of a normal, a good father attitude. Why should you spoil things? You learn to your children. I've been learned by my parents to eat my bread to the last pig and not leaving bread in my plate. When I was served by my mother to eat something, I was pleased. I was asked to eat it. What I did with my kids, and I suppose you did with your kids. So why should architects escape to what is normal human attitude? And also it's a game. When you think about it, our job is really one of the most funny jobs you can imagine on the planet. and also a responsibility because we play with the happiness of other people. So, thinking about your question, innovative material, and this is a very, very good point. Sustainable design doesn't mean you should work exclusively with earth walls. Yet, you should use earth walls when it is the best solution. And at the end of the topic, and it's a very funny story, I have here some samples to show you what technology can bring. Of course, in India, you do enjoy, at least in the central and southern part, a lovely climate, but here in Belgium, it freezes. So nowadays, I don't think it's 3 or 4 degrees centigrade today. So since half a century, double glazing was invented in the States around 1940, I think, and we're still using this double glazing, creating a great amount of garbage. The side of it is full of silicone or aluminum, and it's dumped in the ocean. About 30 years ago, a crazy teacher at University of New South Wales in Sydney invented vacuum glass. And vacuum glass has this, and you don't see it of course, but this has a U value of 0.4. That means it is as insulating as a triple glazing of 60 mm width, and it is only 6 mil. How is it possible? By just creating vacuum between the two pieces of glass, and they prevent it to collapse to each other by little high-tech 0.3 millimeter diameter columns, 150 micron thickness, so you have 150 micron void vacuum in between those glass. So the guy in Sydney invented that, but he, of course, as an explorer, had a small sucking device on the glass to be able to suck the air out of it. And it is a Japanese computer engineer that found a solution to avoid this sucking device. So, and the side of this glass is ceramic. So, of course, and maybe I'm crazy, but you see, this thing is now has been produced already in the States. I learned it, by the way, yesterday, and they stopped production. I don't know why. Another production started in Belgium. It cost a fortune a year ago, halved already today, and they think they're going to be able to produce that at the normal price of double glazing within the next 10 years. And you may know that those two crazy, magnificent, they're not crazy at all, intellectual, James Arbit and Tony Seba, which we have produced free of charge PDF on the website, a book called Rethinking Humanity. And this is really a wise thing about technology. So we should love technology, control technology, love science, control science for our health, for just good sake, for just as an aesthetic approach. And Seba is well known for his advice to main American corporations, and also speak about the S-curve. And let me take a short. You see, we do have a lot of computers, but this is still very, very handsome, and we use it permanently when we make brainstorming. This is time, this is the cost, and we put here another thing, market shares. So the market shares goes like that, at the condition that the cost goes like that. So that's typical. Everybody speaks about the SIBA S-curve. It is right, and vacuum glass is exactly that thing. And I can, in my short experience, I can already tell you that is true for many products. Speaking about concrete, now you're able to make a concrete block without Portland cement, just by injecting CO2, creating artificial stone. So why should we still use Portland cement if you can use CO2? Just take it back. Problem with CO2, it's been diluted, so you better catch it out of a chimney before it's diluted in the air. And so now it's so funny, we're using it permanently, and some of our, and it is, you see, recycling has a lot to do with high tech and being quiet. I'll show you some examples. This is a fabric, and the example. And this is done with the rest of the bobbins, on the sewing machines from Tessitura Umbertino in Vienna. I don't remember why I was there a couple of years ago, and discussing with Umbertino, I saw, they were weaving those outstanding dresses for all the kings, queens, big stars, and whatever. Fabric that cost a fortune, but at the end of the weaving process, they still had some rest. And I asked Umbertino, what do you do with that? Oh, I give it to the kids of the village. So you're crazy? So I'm crazy. And so I suggested him to reweave on the cotton thread all the rest of those mountings. So in this thing you have gold, you have the most precious material you can imagine, and this is good to the basket. So although it's about, I think 15 years ago, I developed that with Umbertino, and you have all sort of density, and what you see them, all sort of density. I had a problem with the fireman, because of course this can burn, as we can burn, by the way. So next time we'll be obliged to wear fireproof gloss if it continues like that. But so amazingly enough, I have not yet been allowed to use that for curtains, to make fabric, sound absorbing fabrics on the wall at a zero cost, but what a poetry. And what is nice as architects is that we should invite other artists, poets, musicians, painters, sculptors. I mean, on one side, and the craftsmen on the other side. It's also part of this recycling. It's a big community of people, girls and guys, saying, let's make it fun, let's make something nice, let's make a piece of art for everybody, for daily use. We all know how the quality of space, and remembering my first trip to India, I remember how I was bluffed by your art of living, your outstanding culture and refinement and everything. I mean, it's still bluffing. I'm bearing of emotion remembering those days, discovering your way of living and your culture. And you're busy with that. I mean, we should learn from you permanently on that. So who am I to give you that? Now, the funny thing is that in Italy, because we're busy in Naples with some projects, and the mayor of Solofra, which is a small city close to Naples, has a lot of fabric creating leather. And he heard about the story of Umbertino, so he called me to his little village, and I met all the guys making leathers. And this is also for the most chic, companies making handbags and leather, whatever. And I asked them stuff getting out of it. And this has been done here. And you know what? To do that, it looks simple, but you had to get the highest specialists from 3M in St. Paul, Minnesota, to find which could be the best glue to glue those whole pieces together, because it's not so obvious, you see. So again, this mix of handicrafts, of high-tech, is permanently necessary. And I can show you off. I get out of one moment, I put it back. Something quite different. If you go on a website, you're going to see a ball, plasma TV. I don't remember the file number. It's a isodome structure. I invented it at MIT 50 years ago. They unable to do it. By the way, at that time, although I was working on the big IBM 360 of MIT on my thesis, my little jokes I had to do it by hand on a drawing board, and it's only a couple of years ago they were able to modelize it in 3D with the software. But then afterwards we had to build it, and just to make a small triangle bearing 20 meters with a piece of glass requires many technologies. First, a robot driven cutting machine to be able to make all those triangles all different. Then a glass maker who can provide me with ultra, extra, whatever, crystal clear glass, which is not so obvious because most of the glasses are produced with a lot of iron oxide in it, which makes them green, as you see. And then finally, again funny 3M, to have a glue that would allow us to glue the glass on 4 mil, and to be sure that within 50 years, with the action of the elements, it would still hang on. So, you see, technology and tradition are permanently there. And other thing, I mean, this is very funny. It's a young engineer who has decided to use electrical equipment. He collected the garbage, making a kind of stone out of it, with bakelite and whatever. And mind you, he has been able to produce tracks in this, whatever, plastic concrete at a competitive price for cable tracks along the railroad. So this guy invented that one day and is now making a small industry out of that. So again, you know, it's a, and as you think, I never would discover that in India, but even back to old Egypt, the possibility using electrical current to depose gold on the tree leaves. What do you call it again? I forgot the name in English. But you can, with an electric current, transport atoms of gold on any support. Well, Egyptians were remaking those objects, and this is really high tech. And it is only since the century that the technology is now mastered. And we can continue on those things. Oh, another very funny story. Just give you another example. I have a more heavy example. It's not nice concrete. But we're making a flooring in a public place, and you all know when you get into a public space that on the floor, you see it's decorated with chewing gum. Weird invention. So of course it's the cleaning of public space with chewing gum is quite a story. So I just have to make a public space in a very chic suburb here in Brussels, and just to, as a joke, I told them, you know, chewing gum is not handsome enough for you. You put money in it. And this is fun and nice, you know, how you can think of things. And then, so I said, okay, we're going to use your spare money, you know, from all the countries of the world, and we'll put them in the concrete. And then if you have a real chewing gum by the poor people visiting you on your nice floor, nobody would care. Now, the idea was okay, but then we started to say how we write it. And this sample is 2 years old, nearly 3 years old. It has taken us 3 years, and the bright brain of a young engineer at a company making concrete blocks, to whom I explained my worry, and he said, no problem. And he has been able, and geopolymer please, not with and it's too heavy to bring it in the meeting room, but we are making with geopolymer, with spare money, also recycling, because what do you do with that? And the guy is just, and because I knew already that the only way to get those pieces of money anchored in the concrete would be to have a kind of start, a piece welded on the piece of money. But imagine there are about 55,000 pieces of money, and someone went and that, so we had to find a robot to do that. And this young guy, named Bert Pandis at IBM, found a way to do it with his robot, and to be within a normal price, to make a public space flooring, lower than a cheap granite piece, but with some meaning, because of course the idea is that every citizen of this suburb will offer the money to the city, so that the guy can pour it in his concrete. So, you know, it's very funny. Every day we use, and it goes from funny details, mundane detail, to very, very serious issue. And the story of the vacuum glass, for example, is a really, it's really a question of ourselves in our cold countries a lot. As we knowing that within 10 years, this will be the standard. What should you advise to a client having big, that wide window frames for double, triple glazing, getting fat stuff, or thin? I still have a minute. It's okay, because my team is very worried about my discipline. They know I'm totally undisciplined. I'm very surrounded by very disciplined people. So now I take your list. Okay. Another lovely subject you're proposing is human resource management in general. First rule: communicate. Everybody is allowed to make a mistake. No, I would not say that. Everybody here, at least, is invited cheerfully to make mistakes, because it's the only way to invent or to discover. At the condition he say he made a mistake, or you say, I'm going to make a mistake. You say, oh, you're going to make a mistake? That's quite lovely. Let's look at it. So I think the total trustability in the team is to enjoy this possibility of sharing work is trust and communication. And then discipline, and I give you a detail. The way we mention dates on documents are different in the States, in India, in China, and in Europe, whatever. But we are used since long, when we send mails, to have year, months, day, hour, minutes, and seconds if you want. So it's the only way, and it is the ISO standard since I don't know when. So please, when you produce a document, make it ISO. Year, months, day, hours, minutes, seconds, logic. Because if not, you can really get injuries on site. And I've been witnessing some big accidents because of just this misunderstanding. January the 2nd or February the 1st. This is a typical example. And after that, another thing, because I'm speaking to young future colleagues, students in architecture, and by the way, try to be a little engineer as architects. You cannot imagine how we as engineers are using rule of 3 to get a first idea of an order of magnitude. And this is at your reach. You can, by training a little bit, by taking use of, playing with figures and numbers, you'll be amazed to see how fast you'll be able to design your structure, basically, and it will not be so different after the engineer intervention, calculating, liquid flows in sewage or water distribution. If you need some mechanical ventilation, the size of ventilation pipe, the size of ventilation groups or pumps, etc. This is really no big deal. Why do I tell you that? Because it's years, it's really decennia, to allow everyone here to express himself freely. We developed a system of putting on every document a small sticker, which we call a DC, design concept, with the file number, a date, the name of goods, we made the sketch, the guy who has checked it, and finally me who had to approve it if I'm not drawing it. And mind you, this way of doing relax the brain of everyone, because we know we have it. Okay, 2 months ago, wow, how have we been able to design that? But at least we know from where we were coming, and we know that we still have a long way to go. And this DC process is really, we're enjoying it. I think everybody, not to make me pleasure, but we're really enjoying it. It's a tool of communication. By the way, please, when you communicate with someone by mail or by letter, put the protocol number your mails, 1, 2, 3, 4, 5. It is a detail, but I can tell you, if you're working with many people and in many companies, many partners, instead of saying, the mail of 2020, November 20, this hour, say mail number 2055. It's much faster, and with a computer you find it much faster than being obliged to blah blah. But I can continue on. What energy? Energy efficiency. I told you already. Did I talk about? No, I didn't think about that. When you calculate, I just diverted to something else as usual. When you calculate, if you want to calculate the energy, you calculate it in what it costs. And of course, some contractors have higher price than others, but globally, the cost of construction gives you a fair idea of the embodied energy. And when you calculate that, here in Belgium, the cost, the energy, the embodied energy, is between 3 and 10 gigajoule per square meter. So this is a huge amount, and the energy spent, even if you're an inconsistent person and you spoil a lot of energy by running the building, you will never spend as much money as the energy you used to put in the building. So you see about the important things, just what is a question, and be careful about that. And I give you another example. Of course, here in Europe there is an obsession of airtight building and having mechanical ventilation. So what that doctors tell us now with the COVID, so please open the window to ventilate. So all those technocratic efforts to make water airtight building is just ruined by a very simple pandemic, because the technocracy tends to ignore that we're living objects. And I'm not saying by that you should not make an airtight building, but that you should think about the mechanical ventilation, which is done with your arm opening a window. So I'm just checking you because you made a nice list. Yeah, so you see about the carbon footprint, to be very careful about those technocratic calculation and the BREEAM certification. The idea behind that is very nice, but it is unbelievable, and we have a lot of buildings certified, whatever, but when I see the amount of energy, the amount of administrative time spent to just demonstrate that we make an ecological building. If you imagine that you spend this time in thinking to make it, instead of spend the time to prove you have made it, you make a step forward. So I think it should be an attitude, and those administrative stuff, yeah, okay, it's maybe for business or for commercial activity, fast discussion we all need also, don't spill in the soup. But when you make a design, just calculate what you should calculate and spend the time you need in useful thinking, not unnecessary thinking. So, but we do that, but I think it is counterproductive, although acknowledging that, it's part of the game. The modules of prototype this is the idea of having modular things you can repeat is since long in the air, and I've seen so many engineers and architects with such a goodwill and wish to do so. A building is mainly depending on the genius looking. What the site is imposing. And so, except if you want to make site barracks or army barracks or runway hangars, which are also useful, but you're not supposed to live in a runway hangar or in a ship container, and because when you could, of course, it could be quite useful for some scary moments, but if you're in peace, if you're wealthy enough to pay for your little building, you better make it fit with the genius looking, with the site conditions. So the modularity and is to find a nice size, to have a standard door frame. Yeah, why not? I mean, that makes sense, because the door has nothing to do with just looking. To see a crane, you will not cast in bronze every crane you're doing. So the interesting thing is, where do you stop getting modules? Where does notion of modules start with? So one of the last issues you were addressing question is about urban planning and the bad use of high-rise technology. High construction makes sense in some case and might solve urban issues, and given a nice answer, a humanistic approach to city living, at the condition that you don't make a central core with divergent space around it and then make any funny shape around it. You should make them porous, thick, with holes in it, and vertical villages. And just for the funny, I'm saying that since decennia, but the first client who just found it obvious is Don Gao in Suzhou, China. And we are designing, for the moment, you go on our website, Positech, if you go, you see, it's really a porous vertical village. And mind you, in Suzhou it's a tropical climate. We will have no airco, no mechanical ventilation. It's a positive energy building, and no big deal, you know. And discussing with the client, he told me, yeah, well, that's nice, that's a dream. How much will it cost more? I said, I'm going to try to make that for an extra cost of 30%. Say, okay, go to 30, I agree, because he realized that he could find that back. And thanks for me, we are in that margin. So it is not crazy, and after all, you better put your money in space than in fabric that can wear out, materials or equipment that breaks. Thank you for your attention. Hoping to see you in India one of those days. Bye-bye.